Okay, so find your example sheets, and we were on number 5. We already did the first 4 together. And number 5 is very similar to question 16 from the displacement velocity acceleration sheets that we just did. So it says two bikers are 400 meters apart and begin to pedal towards each other. Now here's the difference for number 16. The first one accelerates at 0.8 meters per second squared and the other one 0.6. In question 16 it was easy. We could take a shortcut because the accelerations were the same. But in the second one, this one, they aren't. So no shortcuts, and actually none of them will be as easy as number 16 was. So you'll need to do them any like this way. So biker 1, they start from rest. So VI is 0 for both of them. And then it says biker 1 accelerates at a rate of 0.8 meters per second squared, and the second one at a rate of 0.6 meters per second squared. How long before they meet? Okay, so you need to imagine, here's biker 1. Whoops, that's supposed to be the handlebars. And here's biker 2. Okay, and they are 400 meters apart. So one of them is going to travel this way, one of them is going to travel this way. What must be true about their two delta Ds? They should add up to equal 400. So delta D1 plus delta D2 should equal 400 meters. We don't know what either of the delta Ds are though, and we don't know how long it takes. So again, we have two unknowns for each. We're going to need to use a system of equations. So whenever that happens, find your expression for delta D for the objects. So we have a VI and an A, so you want to use VI delta T plus 1/2 A1 delta T squared. And for biker 2, VI delta T plus 1/2 A2 delta T squared. The VI delta T terms are 0, so our delta D1 is really 1/2 A1 delta T squared. And our delta D2 is really 1/2 A2 delta T squared. And so now we can sub them in to our equation that connects them. So it'll be 1/2 A1 delta T squared plus 1/2 A2 delta T squared equals 400 meters. Now resist the urge to fill numbers in. Okay, if you want, you can multiply everything by 2. So this will be A1 T squared plus A2 T squared is equal to 800 meters. And you want to solve for the T. So you're going to do that trick that we did on the math sheet. You're going to factor the T squared out. And it'll be brackets, left in the first term A1, left in the second term A2 is equal to 800 meters. We want to solve for T squared, so divide both sides by A1 plus A2. So T squared will equal 800 meters divided by A1 plus A2. And now you can fill your numbers in. So 800 meters, and A1 was 0.8 meters per second squared, and A2 was 0.6 meters per second squared. So you'll have 800 meters on the top and 1.4 meters per second squared on the bottom. Divide, and then don't forget after to take the square root. So before the square root you get 571 or something like that. And after the square root you get 23.905 seconds. This is how long it will take them to meet each other. Okay, that's the first part. How far has each traveled? So now you go back up here and you fill it in. You fill in the time into their delta D equation. So 1/2 0.8 meters per second squared times 23.905 seconds squared. And when you do this, you get a D1 of 228.57 meters. So that's how far the first biker has traveled. Then you do the same thing over here for D2. 1/2 A2 was 0.6 meters per second squared And again, the time was 23.905 seconds squared. And when you do this, D2 ends up being 171.43 meters. How do you know if you've done it right? These two should add together to give you 400. And if you type them in, you'll discover, look at that, they do. All right, example number 6. Two cars are both traveling 14 meters per second, but one is 20 meters behind the other. Okay? So here's one. Here's the other, and this distance between them is 20 meters. So we'll call this car 1, we'll call this car 2, this guy's going this way. Okay? So so they're both going VI 14 meters per second. They're both traveling 14 meters per second, so this one also 14 meters per second. The one behind decides to pass and accelerates at a rate of 4 meters per second squared. So A for this guy is 4 meters per second squared. The one in front, unlike some of you maybe as drivers, it doesn't speed up. So this is going to be like a VAV. Okay, and the question wants to know how long before the cars are side by side. So this distance is going to be delta D2. And this distance is going to be delta D1. And so when D1 gets up to D2, the times, whatever the times are, they're going to be the same. Right? The time that it takes D1 to get up side by side with car 1 side by side with car 2 is the same amount of time that car 2 has to travel. So we can get an expression for D1. It will be VI delta T plus 1/2 A delta T squared. VI is not 0 this time. We can get expression for car 2. It will be D2 is equal to VAV delta T. We can't find either of these at the moment because we don't know the D's or the time. But we have a connection between the D's. Look at the picture. D1, this big long arrow, must be equal to D2 plus the 20 meters that it's behind. So D1 must equal D2 plus 20 meters. Once you have that, now you can fill in, instead of D1, you can write VI delta T plus 1/2 A delta T squared. And instead of D2, you can write VAV delta T plus 20 meters. This might look awful, but remember that VI was 14 meters per second and VAV was 14 meters per second. So these two terms are going to cancel each other out because they're exactly the same. So all you're going to be left with then is 1/2 A delta T squared is equal to 20 meters. You're solving for T, so multiply both sides by 2 and divide by A. So on the top will be 40 meters and on the bottom will be 4. And you'll end up with 10 seconds squared. Take the square root and you should get 3.162 meters per second. No, just seconds. 162 seconds. Okay, how far has each traveled? So now you take this time and you fill it back in up here. So delta D is equal VAV delta T. So 14 meters per second times 3.162 seconds should give you a D for car 2 of 44.272 meters. Okay, go over here and do the same thing for car 1. 14 meters per second times 3.162 seconds plus 1/2 of 4 meters per second squared by 3.162 seconds squared. And when you do this, you should get 64.272 meters, assuming you didn't round too much. Lo and behold, it's 20 meters more than D2, which is what it's supposed to be. You must have done it right. Okay, so example 5 and 6, there you are.